I'm going to be doing an update on what I presented last year. I was on this exact same stage last year, and I was trying to convey the importance of the scaling laws to the audience. The scaling laws, for those of you who are not aware, is a very important principle for models. But before I get there, I just want to briefly touch on, what is Anthropic and why are we different? So Anthropic is not just a startup that happens to be building models. We are also a research lab, which means that we are constantly putting out a very large stream of exciting and interesting new discoveries. There's been, in just this last week, we published the persona vectors finding, which is a fascinating thing, which I hope I'll have time to get to. And then we're also a think tank, which means we have a policy team that is engaging with folks in government, policymakers, all throughout the U.S., the UK, and various the EU and various other regulatory bodies throughout the world. So when we think about AI, what we're attempting to do is make sure that AI goes well. So we are incorporated as a public benefit corp, as opposed to a traditional corporation, which means that we can put public benefit ahead of profit. And when we think about AI going well, we mean AI going well for everyone, not AI going well for just Anthropic. So when I think about that, and when I think about what's going to be in this presentation, my purpose in conveying what's going on right now is to push specifically on things that are important for all AI applications. So I'm just going to briefly mention Claude. It, of course, is our product, and it is something that's interesting. But actually, I'm going to be talking about the much broader AI ecosystem and how we can all improve the security defenses, because that's part of our mission. So I put this graph up last year, and I said, if I had to predict the future, I would predict that approximately 12 months from now, models will be 4x more compute having gone into them. And lo and behold, it's 12 months later, and that is exactly what has happened. Models are much more powerful. This is a graph of all of the compute that has gone into models since 1957. So at the lower left-hand corner is the perceptron, and then the upper right-hand corner is Claude 4 Opus. These little blobs represent every single AI model and the amount of compute that went into those models to make them do the thing that they do, whatever that is. If there is only one thing that you take away from this presentation, it is that this graph has been holding almost constant for 70 years, and it seems very likely that it will continue to hold constant for the next few years. And so speaking from my perspective as someone who works at a frontier lab, based on everything that I can see, I would speculate that this will continue to hold, and we will be back here in 12 months, and we will say that another 4x doubling of compute has gone into AI models. So, put aside Anthropic, put aside Claude, think about all the things that AI can do today, and imagine what does a model that's 4x more compute, having gone into it, versus what is available today. Think of all the things that are happening right now with the vulnerability discovery results that came out this morning for the AI Cyber Challenge, all of the coding automation that's happening. These models will get smarter. That is going to happen, and it is a very predictable outcome. So, so I'll just briefly touch on Claude. Of course, I think most people at the conference now have discovered Claude Code and the impact that it's having on the way that we think about doing software engineering. There is now a name of product code for everything. So we have lots of models that are also doing agentic coding practices. This is an example of taking model intelligence and organizing it into a tree where the Opus model at the top or the Sonnet model at the top is using and calling out to smaller models to delegate subtasks. And they sort of work together in a concert to make it possible to automate engineering tasks that can take up to like an hour. And folks at Anthropic are now in the situation where many teams will write down what they want to do and then go to a meeting or go to lunch and then come back and do a couple little edits and then check in that code. So as an example, we're in the situation now where 90% of all of the code in Claude Code itself was written by Claude Code. So that's just I think a preview of what we're going to be seeing in engineering teams over the next few years. We're also using Claude Code in other places as well. We can use it in a CI pipeline or CD pipeline. Those are all really interesting applications. But we are continuing to focus on this. And I will explain more in a bit why that's an important principle. So why did Anthropic focus on code first? That's an important question. And I think the answer is how many of you actually in the audience, can you raise your hand if you are AGI pilled? If you know what AGI pilled means, just raise your hand. Okay. All right. So this is the, for those of you who didn't raise your hand, this is the assumption that models are going to get smarter. That's all it is. That's all it means. And to be AGI pilled is to assume that as models get smarter, they will take on more and more work. So one of the things that is very important about what we think about with reinforcement learning and the way that neural networks are shaped and the way that things will be playing out over the next few years is we need to get to a place where the model gets smarter at making new models. And to do that, you need to be able to write code. So what we've done is we've put a lot of engineering effort into making Claude good at writing code, because now we can turn Claude at the process of making the next Claude. A very trivial example of this is making a reinforcement learning environment for a specific task. You say to Claude, make me a reinforcement learning environment that solves math problems for specific kinds of addition or subtraction or something like that. Very trivial task. Claude Code can automate creating a reinforcement learning environment for exactly that specific task. And that is an example of this flywheel effect of reinforcement learning getting better over time because the models themselves can supervise their own learning process. This is a very important principle. This is maybe the most important thing happening in AI right now. And the reason Anthropic focused on Claude was specifically this. So you can imagine as the models are getting more and more specifically towards that automation goal, this is the thing that is unlocking that possibility. Recursive self-improvement for some of you in the audience is going to be wait a minute, I've heard that story before. That is concerning. Recursive self-improvement, yes, is concerning, and so that is one of the risks that we've identified in something that we call the responsible scaling policy, which is how we at Anthropic think about what are the risks associated with increased model capability and increased model autonomy. If we get to, I believe in the most recent version of the RSP, 100x, for example, increase in efficiency gains driven by this recursive self-improvement phenomenon that I just described, that is an example of the kind of thing that would trigger additional security controls. Right now, Opus 4 is currently the only model that has triggered what we call ASL3. So ASL3 is modeled after the biosafety levels. That triggered because we don't have definitive proof that it's a material risk, but we suspect that there may be some dangers associated with this model augmenting the ability for people to use it to make bio-related hazards. And so because we are being cautious, we went ahead and triggered all of the defenses that are associated with ASL3 and have rolled those out. There are lots of different ways that the responsible scaling policy governs our behavior. We have ASL3 as sort of a moderate level of security against non-nation state attackers for the security side, and a bunch of safety and trust and safety protocol wrappers to make sure that models are being used responsibly in the wild. But as the threat level goes up, we will increase those controls under this policy. And so there's an ASL4 and an ASL5 being the highest level of threat. So beyond the safety mitigations, something that is on my mind right now, and we're going to talk about how the agents connect to the safety and the security concerns that are emerging right now. But I think before we get there, I just want to briefly touch on what we're seeing in agent land, and what that means for a lot of folks in this audience who are thinking about securing agentic systems. So just for definitional purposes, I think a lot of folks have latched onto the word agent and started making marketing that says I made an agentic, whatever. That could be the case. I think the simplest agent, maybe the simplest agent I can imagine is one like this. Imagine that you take some task that someone does in their role, and it has a specific document that goes into that task, and out of that, person's attention to whatever is in the document, there's a yes or no decision. So that's like in a giant workflow diagram of everything that happens in a business, like maybe this is an insurance adjuster or something, right? That is an example of a single node out of a giant workflow diagram of everything happening in that business being replaced with one quote agent, right? This is one specific task that has been automated. That is a very securable thing. Like that is not something that is very complicated that we have to worry too much about. It makes it very easy to imagine. I know what the inputs are. I know what the worst possible outcome is. I can put some safety guardrails on the agent so it can't reach out to the internet and get prompt injected and blah, blah, blah. Like there's a bunch of stuff that you could do for that very trivial example to secure that quote agent. But economic value is the reason that all of this is happening, right? The reason that people are adopting agents and they're excited about the autonomy is that we want to be able to make it possible for very large sections of a giant workflow diagram of the way that a business operates to be subsumed by an agentic system. And the more nodes that are consumed, the more risk there is associated with that change, right? So I think every organization has an opportunity to decide if I want the safest, simplest process to be automated, I can do that, and I know the risks are very minimal. But if I want the economic benefit of huge parts of my organization to be automated with a giant tree of AI agents and a swarm working together to like fully automate a specific function, that is possible too, but you are also accepting more risk. And so our challenge as security defenders, everyone who's here, is to figure out for the organizations that want to get the economic benefit of those much larger agentic systems, is it the case that we can put guardrails around the way that those systems work such that it makes it possible for us to have confidence that that economic value is being unlocked in a way that doesn't massively increase the security vulnerabilities of that system? So there's just some stuff on this slide that sort of talks to like broadly what the general principle for an agent is. You can just like imagine the hundreds or thousands of nodes in that workflow diagram getting consumed is just a repeat of this diagram 1,000 times, and they're all working together to achieve that outcome. The next thing that happens though, and I think this is a very important principle that is unwrapping now, and I think over the next roughly 8 to 10 months, this is going to be the bigger evolution on quote agents that we're going to be seeing. We've been calling this concept like virtual collaborators internally, and we've talked about it publicly back about 4 or 5 months ago. I was talking about what virtual employees and virtual collaborators are going to bring to the security landscape and the challenges that are coming. So imagine everything that I just described, but add on the OODA loop. Does everyone know what an OODA loop is? Like, it's obviously one of those things that's very common from business. So observe, orient, decide, act, right? You imagine an agentic system that does a very large section of a business process, but in the process of doing it, it learns and adapts. It takes notes. It has a scratch pad. It has some memory that it uses, like some text files to remember what it did before and what it's learned in previous iterations. That kind of thing is eminently buildable right now. The models struggle with long horizon tasks. Like the larger the context window gets, the less coherent the task over long horizons gets. And so any of you who've used Claude Code, actually, I'm really curious, like, could you raise your hand if you've used Claude Code in the audience? Oh my God, yeah, thanks. Awesome. All right, so Claude Code has the compact step. Have you guys seen the compact get triggered in Claude Code? So it's doing that because the context window is getting full, but also the more full that the context window gets, the less coherent the task gets over time. So you almost have to do this like process of refining and remembering what the exact like specific thing that you're attempting to achieve is. That compaction step is exactly the kind of thing that needs to be integrated into what we would call like a virtual collaborator that has this long horizon ability to learn and adapt in the environment. So this is coming, and it is going to radically, I think, alter the security landscape in a way that is quite profound. So let's talk about what those implications are. First, I should say, on the security team at Anthropic, we are using Claude as much as we possibly can. And that means that we are doing things like automating ticket queues. Obviously, everyone's doing that, but I think it's worth mentioning that as we evolve the way that the ticket queues work, we're thinking about what it means for folks who are really good at that, making the next step in their career, moving to up the engineering ladder to more senior roles. our application security team has a form where you go to upload your design doc for whatever launch that is coming up, right? We have a system, an agentic system, that goes through that design doc and pulls it apart and looks for any new vulnerability. It compares your design doc to the hundreds of design docs that Anthropic has already written, and it says, for your design doc, we are going to be changing our infrastructure from A to B. And as a result of doing the change in A to B, like, go through the MITRE attack framework and look for like literally everything that possibly might be a vulnerability as a result of this. And that system is looking for vulnerabilities before a security engineer ever even sees the approval request, which means we're finding stuff faster. We're able to redirect a lot of incoming requests away from that conversation, which makes the team more efficient. On supply chain, we have a bunch of different kind of agentic systems that are sort of working together. We have one inside of Anthropic that is looking for any kind of risks associated with bringing a new third-party dependency into our build graph. We have partnerships with startups like Socket and Armor Code. Socket is doing supply chain vulnerability analysis using Claude and remediation. Armor Code is doing some great supply chain remediation as well. These are examples of agentic systems that are sort of pulled in and part of the solution space. Compliance questionnaires, I think everyone in this room has probably felt like compliance questionnaires are the most boring thing ever. And there are lots of different startups that are trying to address compliance questionnaire automation. We also have automation that we're working on in this space. Code review and defect discovery is actually something that only just started happening in the last month or two. We've had a number of instances now where, and we disclosed this on Tuesday morning when we released the /security-review feature on Claude Code. We've had a number of instances where that security review feature actually detected like a remote code execution vulnerability or a misuse of a third-party library. This is not the kind of analysis you would get from like a static scanner. This is a completely different approach where you're looking for like business logic errors that traverse the entire call stack, and maybe you're contaminating things with with untrusted input. Like this has been very, very helpful. And I imagine that code reviewing code is going to get much better. I don't know, like personally, I feel like human code review is maybe at best 25% effective. And so the bar for augmenting human code review is actually very low, right? You can imagine like an agentic code reviewing system that's like 60% effective would be a massive augmentation on the effectiveness of human code review. And then finally, just I'll mention, automated detection and response is like one of the more exciting things that's going on right now at Anthropic. So we have a system that an engineer put together on a weekend using Claude Code that uses information from our SIM to sort of automate the triage and detection process for like what would traditionally be like a tier 1 SOC analyst type role. So that's an example of some automation that's like really augmented things. The last thing I'll mention is that team also does our red teaming, and one of the things that we haven't quite deployed yet, but I'm really excited about, is the opportunity to use offensive agents like the ones that were used for the AI Cyber Challenge, or like some startups out there like Expo and others that can actually look through like a staging environment for a vulnerability before it ever goes out the door. So I think there's like really amazing opportunities for even black box testing on these things as well. So congratulations to Team Atlanta for winning the $4 million prize. I was just over at the booth chatting with folks, and they were extremely excited about the future of this entire area. We talked about how they're using Claude. One of the things that's really interesting about the way that their systems work, and the other contestants as well, is this is a fully autonomous black box process, right? You make the agentic framework for vulnerability discovery, you make your preferences known to the organizers, and then they throw it into the arena, and you don't have any control over what happens after that. And I think I saw the numbers are like 41 vulnerabilities discovered, 30-something patches generated completely autonomously for those vulnerabilities discovered. This is really important, and I believe Heather Atkins was actually just up on stage a few minutes ago in the same spot saying that they've discovered like 20 vulnerabilities using their Big Sleep system. This is going to be a big step change in the threat landscape over the coming years. So 12 months ago, I said this was coming, and it's here now. And I think this is something that all of us as defenders need to be paying attention to. We need to think about how do we get patches out as fast as possible. I would speculate that for the next 2 or 3 years, this is going to be a rapid evolution of the threat space. And then once most of the low-hanging fruit is caught, I suspect things will go back to normal again. But in the meantime, this is going to be really, really interesting. And I think for those of us here who are thinking about what's happening in AI now, it won't be much of an issue. But there are going to be a lot of organizations that are going to go, oh, like as soon as I ship a bug, somebody's going to find the bug. Maybe I should not ship bugs anymore. Like, can you imagine a world where we just stop shipping software bugs? I think that's where my mind is at. And they're using AI to sort of like scan through the code base, doing that code review, doing the automated black box testing is like a step towards a world where we just never ship the bugs in the first place. So I think it's going to be super important. One thing that I mentioned 5 or 6 months ago in the press that seems it's urgent, and honestly, there's really no good solution for this right now. And so I think I'd be really interested in talking with folks out here. If you have an idea about how we might solve this problem, it is not very clear what the identity primitive that we should use for AI agents is. Everyone in this room is familiar with using a system service account to host a web server or an RPC server or a backend database or whatever. But if you have a system that is as complex as an intern who is like collaborating with you, and it has a Slack account, and it has a name, and it has an email address, and it has a reporting manager, and it gets assignments given to it that it runs autonomously for a week before it comes back with a result, that's starting to look a lot like a human, which means we now have this weird question which we don't have an answer to, which is, how do I identify these things? Do I use human accounts because they're going to be logging into the web browser and using the web browser just like a random human would on a VDI? Or do I use system service accounts and have these like massively complicated graphs of like spinning up ephemeral VMs and running a headless Chrome browser? And these are questions that nobody has answers to, and these are very challenging problems to solve. We all know that humans onboard to a company and they accumulate more and more and more access to systems over time, right? That is just a general pattern. So if we go with the human identity path for these agents, these are the ones that are incredibly complicated, we're opening ourselves up to a world where they will continually ask for more permissions to do things, and then you'll have like multiple systems all connected to each other through an agent that is potentially exploitable through vulnerability. So that's an important thing to keep in mind, and we don't necessarily have a solution for yet. So this is an important space. Lots of startups, by the way. I am aware of like 15 startups that are trying to solve this problem. I'm really interested if anybody has any solutions here. I think one of the things that's on my mind, though, is maybe we won't solve that in time. Like maybe there will be so much economic demand to roll out agents. Maybe your CEO will come to you and say, I want everybody on the team running agentic coding, and they all have to be doing agentic coding by the end of the year. And we won't have any of the solutions in space that I just described. And you'll have to figure out what the security solution is for that environment. In that world, maybe the incremental thing that we can all work on is augmenting our detection and response teams. If your detection and response team can detect that agents have gone off the rails, then you're in a pretty good situation to actually be reactive as opposed to proactive rather, to anything that's going to be coming out of agents. So there's a lot of things that DNR teams and trust and safety teams can do. You can put guardrails on these kinds of things. You can understand what the outside worst case scenario is. You can build profiles of the way the agents work. You can sort of build a bell curve distribution of what normal behavior is for a particular agent, and then if it goes outside of that distribution, you know that you have an alert that needs to be fired. Starting getting into UBA. All of those are really important principles that I think would be important things to consider in the future. So I think DNR is going to be maybe the most important thing that's going to be changing with agentic systems rolling out. And as a last note, 12 months ago, I stood on the stage and said, hey, confidential computing is pretty awesome. I'm thinking a lot about confidential computing. Wouldn't it be great if we did confidential computing? And I have an important update on that. We are very close. We're nearing the finish line on the engineering work to actually launch that. About a month and a half ago, we pushed out a blog post saying We had an outside engineering experts come in and do an assessment on our confidential computing implementation. And we're very close to having confidential computing launched on Amazon, who's been a great partner in this. The idea behind this, if you didn't see last year, is that you want to be able to say with confidence that everything that's happening with the model weights is inside of an enclave that is completely impossible to tamper with, whether you're an employee of the cloud provider or an employee of Anthropic. And that includes the customer prompts. Like the customer prompts can go into the enclave completely encrypted, and the model weights also can only be decrypted inside the enclave. And so if there's any opportunity for any kind of insider risk threats, this is a great mitigation for that, for both customers from a privacy perspective, but then also for some of the things that we're thinking about for SL4. And with that, I think I will end there. Thank you.